Hi, everyone. That's pretty cute. Maybe I should have substituted the background with this. Yeah, let's do that. Was it? Expand it by 5 pixels. All right. There you go. Masterpiece. This is what we're doing today, as you probably would have guessed. Insert interval and to some. Alright, let's start. Yeah. You guys ready? 'Cause I'm ready. Always ready. Yeah. Check. Alright, alright. Insert interval. So how do we do this? Oh wait, well, I should move myself back. Alright. So interval. So this is what we left off last time. Oh. Where? Okay. Alright. Let's go. So pretty much what's happening here in this problem is we're gonna be we have a group of intervals. So, and then we'll be inserting an interval and then merging it. So the logic here is really interesting. I mean, it's not sorted. It might not be sorted. So it would be 3, 7. It could be like that, and then it could be like 1, 7, comma 1, 7 should be 1, 7, and it could be 3. No, no, it could be 8, 9. And in this case, it'll be kind of difficult to merge it because you don't know where to insert our 7, 8 interval or 7, 10 interval. Alright, so we have, okay, so this is an example. Here. Okay. So this is the interval. And this is the intervals. So a good way of doing this, right, if it's sorted, it'll be easier to tell because you can just go and loop through it. Otherwise, how will we know which where is which? We won't know where to insert this 710. So we must sort it. You know what sorting does? Sorting takes our time complexity to at minimum O of n log n. So t equals O n log n. So hopefully we can keep it like that. Then we could say in here, the solution. Solution 1. Solution. What's our solution there? It's sort. Then insert. Then merge. Insert. Sort. Insert. Sort. Insert. Then merge. Insert merge. Okay, so that is the thing that we're going to try to do. So say this is sorted then. Oop, 8, 8, 9, 1, 7, 1, 7, 9. What this means my handwriting is good enough for you guys to read. But 8, 9, 8, 9, 1, 7, 8, 9. What happens now is when we try to merge to 710, 710 will come in here and be return merged. Merged will have an array. And this array will have 1, 7. Once we reach 1, 7, be like, hey, can we insert it with, merge it with 7, 10? And in this case, it has an overlap. So we have a loop. It initialize variables. Loop. You know that we had to initialize the merged array. Loop it. We see if mergeable, if overlap, then we merge. Merge then or add to merged. Oh, yeah, one second. Gonna move this. Okay. Now we have to do sort. Remember, start with sort, then we init merged. This is a pseudocode here. So it overlaps, so you check to see if overlap the interval and intervals. So if interval at I overlaps with interval then we merge. So what do we merge in this case? All right, so we have 7. What we want to put in here is 7, no, is 1, 10. This is what we wanted to do. Okay. So merged. Okay, so we'll have a intermediate. So this is an intermediate value. Okay, this is intermediate value where we have what would be called merged, and this is merging. We'll have new interval. Yeah. Yeah. Okay, so this is how we would do it. So we have new interval. New interval, you first start off with 710. And then if you can merge it, right, if this overlaps, then you update the new interval. Alright, so the new interval will now turn into 1, 10. Merge into merge with interval. It isn't. Oh, so never mind. New interval is this. New interval is this. So interval of that. We update the new interval to that. Then it checks it again. It sees that we can merge it. So it'd be it's still 110. And then we at the end we have to update the merged array. How do we update the merge array? Where will we update the merge array? So we loop finish it. When the loop finishes, we check how do we know if we already inserted a new interval? I mean, we could have a variable that says inserted or not, and if it's not inserted yet, then we can insert the interval into the merged variable. Is there another way of doing it though? Yeah. Is there another way? So once you merge it in a new interval, how do you deal with that? So it's just that it's 110. Okay, so we need a condition. Right now we're thinking of the condition to put the new interval into merged array. I mean, we could do a condition of how we know else. Okay, so interval. So if okay, so we do an else statement, and if it doesn't overlap, then we know that we can merge it, or we can add it to merged. Add to add a new interval into merged. No, add not new interval into merged. It doesn't overlap. We have to add interval at I to merged. Which means that the new interval is added to. Okay, so you would, yeah, it would have all the values there. But then how do you? Then we need to update the logic at the top. Add new. Mm-hmm. So interval overlaps with interval I overlaps with new interval. You merge new interval I with new interval. How does that work? How's that? I think. Oh, when do you? That's so clear. How do you know when you should send? I guess if the previous time was a merge. Okay. Okay. Yeah, one condition here if we do this. Yeah. Move this over here to the bottom here. And if interval ends before or starts after new interval, then we can add new interval to merged. Then we could have this same condition here. Copy this over here as well outside of the loop. Okay, so that means that you can, yeah, because we want to, actually, no, can't just copy it and make it there, but it'll be similar logic. Because what we want to do here is outside of the loop, if merged at -1 starts or ends before or if it's empty. So we know interval set length could be 0. Interval could be 0. Well, if merge -1 and C4, or if 0, plinth is 0, we know to return empty. So length of what's it called intervals. Oh wait, never mind. It won't. If it's 0, you can still insert a new interval. Okay. I understand now. So at the end part, so if it's empty, if the array is empty, or if merged is empty, or merge -1, so merge is empty, or merged the last element of merge ends before merge starts, or before new interval starts. Then we add interval, new interval to merged, and then we return merged. Save. Let's try that. Let's try that running through that logic. Oof. I'm creaking so much right now. Okay. Zoom out, and let's try this out. See how it goes. Okay, so we start off sorting. We sort this, so this is sorted. Now we do a init merged. So we're initializing the merge variable, which is the return. And then now we're looping. If interval at I overlaps with the new interval, we merge the interval at I with the new interval. So over here, we got this, so this is merged with this. So 1, it overlaps, so it merged. Nice. So now it does the same thing again. It does 7, that. It's like, yo, 1, 10. That's the new interval. And then outside of this loop, we end because we finished all the intervals. We say if merged is empty or merge is empty. So now we add new interval here. So it's 1, 10, which is the solution. Perfect. So it works for this problem. This algorithm works for this first one. What's going on? Tab. Do we have alpha lock? Nah, here it is. Right, so now say new interval is something else. Like 2. No, 1, 2. 3. No, 4, 5, 7, 10. And we want to let's do 8, 10. And then we have new interval to be 5, 6, 7. Okay. Now we want, let's see how it would go. So merged is in right here. The new interval starts off with 6, 7, 7. What we do now is we're going to say, hey, interval I overlaps with new interval. So it doesn't. So we go to the next one. So if interval I starts after new interval, this starts before the new interval. The intervals end. or no, new interval start, I mean. So this is yeah. So if it starts after new intervals end, then we add it to the new interval, right? Because we know that for sure that at that point interval is before interval I. Nice. So it's not. So we run this, we run to that, which is add interval I to merged. So 1, 2. And then it just goes here again. Same thing. 4, 5. And then we notice we're in the else again for this. And then we see this starts after interval end. So we add new interval to merged, which is 6, 7. And then we add the interval 8, 10. Perfect. That's how we want it to be. We'll return merged, and it's good. Good over here, we know that merge is not empty. Also, merge -1 does not end before new interval starts because -1 is the same interval. No, nothing. 8, 10 ends after new interval starts. Then we return merged. Perfect. So it works for that case and this case. Is there are there any other cases? So this is the overlapping case. Overlapping is the no overlap. Is there anything else that we can do? Like empty array. That's typically what you do. Do empty array and 1, 2. We know that merged is right. So merge at that point. New interval is 1, 2. Then over here we check, we loop it. Well, we can't loop it. And then at the end here we do merged is empty. So merged is empty. So we add 1, 2, and we return. So this looks good for all cases. Empty case. Is there any other case though? I don't see any other cases that would be an issue. I mean, we could do, okay, so this is fully overlap. Fully overlap. No overlap. Left overlap and right overlap. I mean, this left overlap and right overlap should work. Okay, so left, so empty, and left overlap. Left and right. Okay, so left overlap, so 7, we do 7, 10 intervals of 1, 2, 3. 4, 5, or 4, 7, and then 11, 12. Left overlap. Oh, this is right overlap. Right overlap. And then if we do a left overlap here, left, 7, 2, 4, so 3, 4. And the same thing. 1, 2, 4, 5. So left overlap. Interval is 7, 10. Okay, how do we do this? I mean, we can simplify this even more. Yeah, this is left overlap. And right, left overlap. Okay. So it'll say merge, it'll check, and it says since this is not overlapped, it'll add interval I to merged, and it'll do that for this as well. Oh, but this one is an overlap, so we merge it with interval I with new interval. So that's 4, 10. And then after that goes to there's no more values. So now we go here. If merge is empty, merge is not. If -1 ends before the interval starts, 4, 7 ends before 1, 2 ends before 4, 10. That is correct. So that's why we add it. 4, 10. Perfect. And then we do the same thing here. Before. And then since one you have 1, 2 is it'll go here. It'll go here because it's not overlapping. So it adds in the we add 1, 2 to merged. And over here it checks this. We see that it's overlapping. So we change this to 4. Oh no, 3, 5. Then we see 1, 2 ends before 3, 5. So we add 3, 5. And perfect. All right, looks good. Logic is satisfactory. Let's do. So we know that this is space complexity of O of n because we have a merged array. So this is the time complexity and space complexity of this algorithm for them. Perfect. So now we're gonna jump over to Leetcode. See if we can solve it. Okay. Intervals. Let's go. Merge intervals. All right, let's merge those intervals. So we have initialized variables that we have to sort first. So sort, let's sort it. Intervals, not sort. And then we do initialization of the merge. And then after that, we can loop it. So for I in range length of the intervals. Check to see if merged, or if the intervals at I is dot the start value. If it okay, so this is checking to see if overlaps. Check for overlap. So if the start is less than, no, is equal to two intervals, if the start is before the end, before or equal to the end, less than or equal to the end of our new interval, oh wait, this is not, this is merge intervals. Oops. We have to do insert interval. Okay. Let's go to code, problems, insert interval. There we go. So if intervals at I is less than or equal to, I0 is less than or equal to new interval, three. New interval at I, and at 1, or yeah. So new interval, the start is before or equal to the end, or if the new interval 0 is before. And here the end is start is, the start is less than or equal to end try to visualize it. So 1, 2 overlaps with 3, overlaps with 3, 4. So this value, first value is less than or equal to in this case, it would be the last value. Let's see, maybe. I think we need two values. So if it ends, if the first interval ends is equal to the start, or is less than or equal to, and the start intervals at I0 is before in this case it would be the new interval at 1 is before the interval at end. The beginning is before or equal to the end of the interval, and beginning interval is less than, it's greater than or equal to the interval at yeah, so that we know that this first value is either grouped with this or joined with this, and then this value 3. Now we have to think about what if the roles were reversed, or or it's not merging from the left side of the, we're merging from the right side of the interval. So this is overlap right, left equals overlap right equals and then we have overlap right, which would be the same, but if the 4 okay, overlap right, let's do 4 5 or 3 5. So overlap right would be this, the right value is less than or equal to the the starting value. So new interval at 1 is the ending value is less than or equal to no, is greater than or equal to at start value. And it has to be this is greater than or equal to this. Ending has to also be less than or equal to value. So less than or equal to the ending value of the current interval. How about completely overlapping? Completely overlapping. So if you have, say, 3, 4, 6, 4, 6 will completely overlap and demolish 3, 5. What would these accommodate? Would this condition accommodate? Because in that case, 4 is before so in this case 4 is before 3. No, not 4 is before. 2, 6. In this case 2 is before 3. So let's say laughing interval at I. At I. In this case, start. Okay, start is less than. Start is less than start, and end is greater than end. So let's see. New interval 0. So new interval 0. This one value is less than or equal interval here. Yep, that's correct. And I interval at 0 is greater than the start of the new interval is before oh my god, this logic is okay. I didn't realize I was underneath the page. Very scuffed, isn't it? But okay. Where's my cursor? Alright. Let's use words. Right? So overlapping is if okay, so interval starts before or let's see, interval new interval starts after interval I ends. New interval starts after new interval after interval I ends. No, that won't work. It starts after or starts before interval I ends and new interval ends before so new interval starts before interval I ends and after it starts. After I starts. Alright, so new interval starts before interval I ends and new interval starts after new interval I starts, or new interval ends after interval I starts and before interval I ends. And then so that 4 starts. Right, do we need all these conditions? Starts or interval ends. And this is why this is intermediate. This is very mind breaking. 1 second. I'm gonna go over to the drawing board because I can't figure out how it's supposed to look. Okay. So what I'm wondering is, how do we determine whether or not something's overlapping? Determine overlap. This is where we're running into a wall. So what conditions can we determine the overlap? So if we have like that, it's the interval. This is the new interval. And then we have, okay, so we have so okay, so this is the main interval. So we move this over here, interval I. And then we have interval, new interval. New interval. So how do we do this? So new interval could be like this. It'd be like this. Or it could be like this. And it'll still be merging. And it could be like this as well. Or this. Or this. Yeah. Yeah. How do we encapsulate all these cases in as concise as possible? That's the thing. So starts before. If this starts before this, if new interval starts before that, and new interval ends before this ends before this. Does it have to end before that though? And this has to end after this. So the new interval has to end after. So if, okay, let's set the condition. If new interval starts before start is less than or equal to current interval at end. I'm gonna add start. And then if this ends after, oh, so this is kind of two conditions. As this is saying, we just focus on this one point, then we know that it'll satisfy this condition, satisfy this condition, and it'll satisfy this one. So it covers all those. Focus on this point, it'll be the same here. Okay. Yeah, okay. So there's only going to be two conditions then. That. Just need more space here. 1 second. Okay. So n start is less than or equal to I start. If this is the case, and n end is greater than or equal to I start, then we can conquer this first point. So all these three, this, and this, that case, so we covered for all three. Then for and then for the last three cases, we can say this. Okay, let's do this. So circles go to that side and triangles here. So we covered all these cases. So if n end oh no, it will be these cases, because we know that these begin, that always begins before. Oh wait, no. Let's do this. Okay, so now we can say for all these ones, these three, these all end, or these all start after this first one. So end start is greater than or equal to I start, and end start is before. All these go before this, and end start is greater than or equal to I end. Okay, so there's just two cases here, and it covers all six. Nice. So pretty much is if it starts before, the new interval starts before, then what happens? And if the new interval starts after, then how do you cover those two cases? That will cover all cases. So if it starts before or equal to, then we have to make sure that the ending is before the start. Ending is before the start. If new interval starts before, then the ending should start after it starts. Yeah. Well, if it starts before, trying to see if we can logically understand it so that everything just falls into place whenever we see this problem again. So if it starts after the end, start goes before the end. If it's no, this won't work. This doesn't logically work, because that would mean that it would say that this is also a merge. The first condition works. The second condition is have to configure. Okay, I understand now. I understand now. If you look at this one point, if you look at one point, or okay, look at 3 points at once. Points. This is all just 3 points. This and this, no, 3 points. That's 3 points. Triangle. So three points after. Okay. Okay, I think I understand it now. Okay, so the first thing you gotta do is look at these 3 points here. And after that, you have to use 2 of the first one, 2 of the first one, and 1 of the second one. This and that. Yeah. So we're saying this is encapsulating this interval encapsulates this point, the start. If this interval encapsulates the start of the new interval, or if the interval encapsulates this point, new interval encapsulates the beginning of the interval. Yeah, works. Because these two points encapsulate all this. Well, these 2 points, well, if they encapsulate this, that's all we need. We cover this, and that. Would it cover more cases too? Maybe, but we know for sure that it will cover these cases as well as all the others. If start is less than equal to start, end less than equal to start, or start the end not end end. We'll be using I end or end start. So if end start is greater than or equal to I start, and if it's after and it's before I end, then we should cover all cases. The proof being we'll cover the cases where if they're the same, would it cover though? Yeah, it would cover because we have less than or equal to. So if they're the same, and then the start is less than or equal to the start, the end is also less than is end is less than or equal to the end. So we cover in the second case. Right, the second case would cover so trying to see if there's a good way to explain this like in an interview or something. How will we explain this without drawing out the diagram like this? How will we explain this very concisely? So overlapping means that it overlaps at one point, left or right. And we can, and what does it mean if it overlaps? Is if interval, one of the intervals encapsulates one of the points. So if we have the new interval encapsulate the first point, or we have interval I encapsulate the first point, yeah, this encapsulates this. If this will encapsulate the first point of each one here. Yeah, we just say if you use the first interval and it covers the second interval's first point, then we got the case where it's overlapping on the left side, get the case where it's overlapping on the center, and we also got the case where it's overlapping anywhere else. Yeah. But it covers all these cases, so I think that's all good. Yeah, so let's do that. Just see. Okay. So the rule here is if overlapping. Oh, let's go back to the code page. All right. So overlapping if left is less than or interval I encapsulates new interval 0 or interval I or interval new interval encapsulates interval I at 0. So did we do that? So be like but the visual, I don't know if that actually works like that. Or interval, new interval encapsulates interval I at end. So interval I encapsulates new interval 0. I encapsulates interval at 0. Yep. But this is okay, so new interval top. I encapsulates new interval at 0. Or interval I encapsulates at okay. This is better explanation of this. If we go back to the visuals, it might make it easier to understand. Okay, let's go back to visuals. So this is just what I figured out after thinking about it long and hard. So new interval here. So if this interval encapsulates the new interval, so any encapsulation. So if this encapsulates the beginning, it will cover any case like this. It will cover this case as well. Okay, so this covers that. And if this new interval encapsulates the end, okay. So this interval encapsulates this, or this interval encapsulates this, the end. We'll cover this case as well. And I'll cover but we'll not cover this case. Where none of them, it's not encapsulating anything. If the new interval is encapsulating everything. And start before this starts before this. And if this ends before it starts, then we know we captured it all. So long on this problem, but I have to figure it out. I guess we could have 4 conditions. We could have 4 conditions. It's like, if we have 4 conditions, it makes it so much easier. Yeah. It's like if this interval eats the top, the beginning, or if this interval eats the end, or if this interval eats the beginning, or if this interval eats the end, then we can cover all cases. Yeah, let's just do that. It just makes everything simple and to understand. Well, let's just default to that, right? So this interval, so interval I eats if interval I eats the beginning, interval I eats the end, or if this eats the beginning or the end. Okay. This eats this. This also eats this. But this eats this, and this also eats this. But if it's overlapping, then this eats this. I want to see if that's okay. I mean, we'll figure this. We'll say till I eats start or end. So the conditions one eats new interval beginning or end. Start slash end. Or this eats new, it eats interval I at start end. This is the easiest to understand, in my opinion. Those are the two conditions. All right, let's go back and code it. If interval I eats interval start or end, and if interval I new interval eats interval I start end. Okay, let's code that out. So if interval at I 0 before new interval on start and intervals I 1 is less than, it should be less than or equal, to greater than or equal to new interval at 0. It's overlap start. How do we, what variable should we use? Interval I I mean, we can do that or that or so this is before the end, and end is greater than or or new or intervals, new interval at 0 is less than or equal to intervals at I 0 and new interval at 0. Oh no, at 1 is greater than or equal to intervals at I 0. Or new interval 0 is less than or equal to intervals I at 1 and intervals I 1. Then we know that it overlaps. Say I don't know, you multi-line like that. And here we go. Here we go. Okay, so now what do you know? If all that is true, one of them is true, then we know we're overlapping. Say, hey, we can merge them. Merge our new interval equals x new interval at 0 in interval and intervals at I max of new interval 0 1 at new interval, oh no, intervals I 1. There we go. And now what else? We have to check to see if our interval is, let's see, what do we have to check? Yeah, do we check to see if we need to add to our merged? Oh, how do we know if add to merged? If new interval, no, if new interval at I at the beginning, it ends, or it begins, then we do merged append, and we'll append new interval. Else but we only want this to happen once. What if it, because it could be before, it'll happen multiple times. We could say continue. Appended. Now it's appended. It's appended. Then we that's all. We want to append it one. I just say appended equals false, and appended equals true. We do that, we would say and appended not appended. And then else we will just do, you know, usual, which is merge dot append no interval. Oh no, interval at I. And then do if merged we do we have to, okay, so we have to make sure if it's less than, if it's, if there's nothing in there, some if merge length of merge is equal to 0, or new interval appended False, false. And I mean, we could just say if not appended. Yeah, at this point, if not appended, then we do merged. Append interval at I. Oh, not interval. I merged. New interval. Return merged. Okay. There we go. Perfect. We did it. So yes, that took a while. Let's check the solutions. You could use a binary search in a binary tree. That's interesting. Huh. Somebody used. Is that Erlang? That's funny. Use MySQL. That's funny. Yeah, okay. Full solution. For interval and intervals, it is a range of the other interval related. This because the new one does not overlap with it. I think we just spent the entire time. Yeah. So we'll have to wait until tomorrow to work on the song or 3 song. Not tomorrow, but another time to work on 3 song. Okay. See if intervals. Trying to see if we can understand this. So the main idea here is that iterating 3 cases. No interval is in the range of the other interval. So my solution is it's four cases, but it's I guess this is probably overlapping too much. Overlapping cases. So the new interval is in the range of the other interval. New interval is before the other. Or if the new interval is after the other. In the range. After, before. Oh, interesting. Yeah, this is more efficient. This is definitely more efficient. Like if you start off with the easy cases, right? So you start off with the easy cases where it's before and then if it's after and then now. So if you have both of them, then we know that we can or see before the interval is before interval one. Oh, if interval if interval ends before this interval, then we append. Else, if interval starts before the interval on new interval ends, else so if it's before, then we'll append it interval. Okay. This person did not even sort it. Is this okay? So it's already sorted. So we get rid of the sorted. Is it going to be even faster? Man. not by not by much. It's before. It's not before. Then we know that it's after. Then okay, we know that it's not before, so we know that n is after. If n is after, and the new interval is ranges before the other, so we can add a new interval and update the current one. So the interval it's before, then we know that it's part of it. Else if the other independent, if it's after, and if it's after, equal to. Oh, okay. I understand now. So there's a if the interval, right? If the interval starts after interval, so there's no overlap. So you're getting all the non-overlaps, and then else. Zero. Do we need this part? I mean, we just do say else, and that's it. Right? Yeah. Yeah, we just do else like that. We don't need the. Yeah. I mean, this solution is interesting, but the way that they do it here, I understand it now. We go back here. We could also do, let's do it like how they did it. We get rid of appended. It's very useful to know because you're pretty much getting all the values for like the easy parts. You get the three cases, then and the else will cover the rest for you. That's so succinct. That's so smart. I love it. Okay, if so, if it's intervals at they also did the yeah, their interval and intervals. Is it in intervals or is it of intervals? I don't think there's of in no. It's in intervals, yeah. Interval in JavaScript, yeah. If for interval intervals, if interval 0 is greater than or is less than, let's see, if it ends before new interval, then we know new interval equals interval at what am I doing? Okay, so we know this is in the beginning, so now we know that merged is equals to that end the interval else if interval at 0 is greater than new interval. So if it's disconnected, and we know that new interval comes first. So merge new interval. If you merge the interval, you do after that. But what do you do with the intervals after that? Interval merge the append interval, and we append interval. Else, then we know that merge interval new intervals equals max of new interval interval 0 minimum function. The max of new intervals interval at 0 interval at 1, yeah, 1. Okay, then return merged. But then we got to do the case where if its new interval has not been appended. And we could say appended equals false, not appended. Then will be merge dot append interval. And we can say here appended true. What? So 0, 1, no, 0, 5, then 0, 1, then 6, 7, then 0, 1, then 8, 9. That's so weird. So merged is pending with. Oh. It's true. Unappend is true. Yeah, let's walk through it, okay? So 2, 5. 2, 5, so we see 2, 5 is 2, 5. Okay, 2, 5, so 5, 5 is the end. 5 is before. No, 5 is not before this. This is before that. So interval at 0, 2 is less than, no, it's greater than interval. So we append new interval first. So 0, 1 is appended. That we appended 5. Nice. So that's perfect. That's what we wanted. Now after that, go here. Oh, so it keeps appending over here. Appended. Okay. Submit. There we go. Perfect. Oh, I guess my solution with the flag is not. I mean, it is necessary, so that's good. Awesome. All right, right. Well, we'll work on two sum later. I'll have to remove the two sum from thumbnail, but all right, I'll see you guys. We'll see if I have time tomorrow to work on two sum. Maybe. I think I will. Or not two sum. I keep saying two sum. Three sum. All right. Good night. See y'all.